Welcome back to our General Awareness course on the Transportation of Dangerous Goods Regulations. In this module, we will discuss classifying dangerous goods and using Schedule 1. I want to start this module off with a question. What are some of the TDG classifications? For those of you who are stuck, think of WHMIS. The TG classes are very similar to the WHMIS ones. As shown, there are 9 TDG classes: Class 1 explosives, Class 2 gases, Class 3 and 4 flammable liquids and solids, 5 is oxidizers, 6 is poisons, 7 is radioactive materials, 8 is corrosives, 9 is miscellaneous dangerous goods, most of which are marine pollutants. You may notice that there are no TDG classes for carcinogens or sensitizers, as there are for WHMIS. As I mentioned in the first videos, TDG is for emergency crews who will, hopefully, rarely if ever come into contact with any particular dangerous good. As a result, the dangerous goods simply do not have time to cause long-term diseases like cancer, and thus such hazards are less relevant in TDG than they are in WHMIS. But how does a product become a dangerous good? Well, there are a couple of ways. First, it meets the technical criteria listed in detail in the regulations for inclusion in at least one of the 9 classes of dangerous goods. But before I explore this statement in more depth, I want to introduce a concept. That is the flammability range. The flammability range is the concentration range of a gas or vapor that will burn or explode if an ignition source like a spark is introduced. If you are below the lower limit of the flammability range, there is not enough gas present to cause an explosion. If you are above the upper limit of the flammability range, there is too much gas present to create an explosion. A classic example of this latter situation occurs in older cars when, if you pump the gas pedal, you would flood the engine. That is, you would put so much gasoline in the cylinders that the spark plugs could not ignite it. Returning to our discussion about how a product becomes a dangerous good, I want to look at the technical criteria for one class, flammable gas. The regulations define a flammable gas as a gas that will ignite when the concentration is 13% or less, or has a flammability range of at least 12 percentage points. If either or both of these criteria are met, the product is Class 2.1 flammable gas. These criteria are discussed in detail in our Transportation of Dangerous Goods classification course. Taking those criteria, let's look at some actual gases. You can see from the lower explosive limit column, most will ignite or explode below 13%. The exception is ammonia, which will not explode until it reaches 15%. So does this mean that ammonia is not a flammable gas? Remember, there are 2 criteria: will ignite when the concentration is 13% or less, or has a flammability range of at least 12 percentage points. True, ammonia will not ignite at 13%, but looking at the right-hand column, the flammability range, ammonia's flammability range is 18.6%, well above the 12% required by the regulations. Thus, ammonia is a Class 2.1 flammable gas. And that is one way a product becomes a dangerous good. You compare your product against the listed criteria, and if it meets any of them, it is a dangerous good. But as I mentioned earlier, there is a second way. If a product is listed in Schedule 1 of the regulations, it is also a dangerous good. So what is Schedule 1? Despite its unassuming name, Schedule 1 is the heart of the regulations. At 280 pages long, it lists most dangerous goods, given their official name, their number, commonly called a UN number, limits on transporting them, and much more. We will discuss all of these parts of Schedule 1 in the next few minutes. Now, products in Schedule 1 are sorted by UN number. This is an excerpt from Schedule 1. Simply a random page, and you can see in the left-hand column the UN number in ascending order. In addition to Schedule 1, there is Schedule 3. This schedule has some of the same information as Schedule 1. However, it is listed in alphabetical order. This allows you to find the UN number and then use Schedule 1 to get the details. So when would you use which schedule? Let's take an example. Assume you want TDG information about car batteries. Using Schedule 1, you could start at the beginning and go down the list until you find batteries, 97 pages later. Or perhaps you do a word search for batteries, and you have 145 entries to go through. Or you turn to Schedule 3 and look up batter. You don't even need the whole word. And there you go. The different types of batteries all in one place. Check the UN number, and then look the car battery up directly in Schedule 1 to get the full details. And there we go in Schedule 1, batteries, UN number 2794, and all of the details that we want. Now that we know how to find something in Schedule 1, I want to discuss what information you can get from there. The first column is the UN number. This is the number we are all familiar with, seeing it on tanker trucks and other vehicles. As the name suggests, it's assigned by the United Nations, specifically in their model regulations. But the products all have names. Why do we need a number? I will illustrate why with a simple example. Look at the word on the screen. Is that product dangerous? Well, that's a bit of a complicated word. Let's simplify it. No takers? Let's use a more recognizable alphabet. Still a mystery? Well, now the ultimate clue. Yes, these are all words for arsenic, specifically in Hindi, Chinese, Russian, and Italian. What do all of these words have in common? They all have the same UN number, UN 1558. The number is common in all countries. That way, given a universal number, one does not need to speak Russian to know that a shipment from Russia with UN 1558 on it contains arsenic. The second column of Schedule 1 is the shipping name. This is the official name of a product. And why do we need official names? Well, one more illustration. What do dimethylmethane and propyl hydride have in common? They are both legitimate names for propane. And it gets worse. These are all synonyms for what product? Simple rubbing alcohol. Now, something as simple as rubbing alcohol can have 8 other names. We could be in trouble. So unless we had some official names, the potential range of names becomes overwhelming. There are several rules about how to deal with official shipping names, which we will discuss in Module 4 on shipping documents. The next column in Schedule 1 is the class. Very similar to WHMIS, the Transportation of Dangerous Goods regulations groups products into classes with similar hazards, such as explosive, toxic, etc. Most, but not all classes, also have divisions, which are essentially subclasses or finer groupings of products. Thus, the class may be 1 digit for a class alone, or 2 digits for a class and a division. For example, Class 6.1 is Class 6, Division 1. Any subsidiary class is shown in parentheses under the primary class in Schedule 1. For example, here we see methanol, which has a primary class of 3 and a subsidiary class of 6.1. Following the class column is the packing group column. Now, the pack group has very little to do with how you pack things. It is, in fact, a degree of danger classification. Packing group 1 indicates great danger. Packing group 2 indicates medium danger. Packing group 3 indicates minor danger. You may notice that Class 2 gases and Class 7 radioactive materials do not have packing groups. One point to remember: the packing groups are identified in Roman numerals to differentiate them from the UN number, which uses Arabic numerals. After packing group in Schedule 1, we have special provisions. These are extra rules that must be followed. They are referenced by number in column 5 of Schedule 1, but the details are actually found in Schedule 2. Question: there are a lot of rules in the regulations. If there's a conflict between a special provision and other provisions in the regulation, which one applies? The special provision takes priority over all other parts of the regulation. Now let's look at an example of a special provision. Under column 5, methanol list 43 as a special provision. So what does special provision 43 say? Looking in Schedule 2, it says, despite Section 2.1 of Part 2 classification, these dangerous goods are assigned this classification based on human experience. Very technical wording, but put in plain English, it means even though methanol does not meet the criteria for being in Class 6.1 toxic, we are putting it there anyway. So what's so special about methanol? As you may know from old moonshine movies, it can cause blindness. But blindness is not a criteria for toxic products. To overcome that, Special Provision 43 puts methanol in Class 6.1 anyway, despite the fact that, if you use the actual criteria, it should not be there. Schedules 1 and 3 also often use the word forbidden at various places. When the word forbidden is shown in the third column of Schedule 1, or the second column of Schedule 2, you cannot transport it at all. For example, dichlorodimethyl ether cannot be transported by any means. As well, something with no UN number at all cannot be transported by any means. When the word forbidden is shown in column 8 or 9 of Schedule 1, you cannot transport it by that mode. For example, the second entry, allylamine, cannot be transported by passenger-carrying vessels, as indicated in column 8, or passenger-carrying road or rail vehicles, as indicated in column 9. The rules are a bit easier for the first entry, allyl acetate. While it still cannot be transported by passenger-carrying vessels, it can be transported by passenger-carrying road or rail vehicles. You will notice that column 9 for allyl acetate contains a value, 1 liter. What does that mean? Values in column 8 and 9 indicate the maximum amount of a product that can be transported in a single container. If a cell in column 8 or 9 is empty, it means there is no limit. For example, we can transport methanol containers of any size on a passenger-carrying vessel. However, we are limited to container sizes of 1 liter for passenger-carrying road or rail vehicles. A question now. If I cannot transport allylamine, the second entry, by passenger-carrying ships, trucks, or rail cars, how can I move it? Well, the devil is in the details. The limits are on passenger-carrying modes. If you don't carry passengers, then columns 8 or 9 do not apply. Given all these classification rules, who is responsible for classification? In WHMIS, it is the manufacturer. But in transportation of dangerous goods, it is the consignor, the person who ships the product. That may be a middleman and may not be the manufacturer. So where can you get the proper shipping names and classifications? In most cases, a non-manufacturer will look at section 14 of the safety data sheet, and presto, there is the transportation of dangerous goods information. In a lot of cases, similar information will be listed more than once. In the case on the slide, 4 times. Why would you think that is? Well, it's because the classifications, although very, very similar, are not exactly the same for all modes of transportation. So here, they list separately the rules for the U.S. Department of Transportation, DOT, which is the U.S. rules for road and rail. TDG, the Canadian Transportation of Dangerous Goods Regulations. IATA, the International Air Traffic Association, setting out the rules for aircraft. And finally, IMDG, the International Code for the Maritime Transport of Dangerous Goods, setting out the rules for ships. In this case, all 4 use the same classifications. But as I said, in rare cases, they may differ. Beyond using the safety data sheet for the transportation of dangerous goods information, I want to give you an idea of how classification, using the criteria, actually works. For example, let's take sodium cyanide, a common product in gold refining. Sodium cyanide is solid, non-explosive, non-combustible, toxic, not radioactive, not corrosive, not infectious, not an oxidizer, and does not bioaccumulate. Now think of our classifications. Non-explosive means it is not class 1. The fact it is solid means it cannot be in either class 2 or 3, which deal with gases and liquids. The fact it is non-combustible means it is not class 4. The fact it is not an oxidized means it is not class 5. What about class 6? Well, we do not have enough information yet to automatically eliminate it from class 6.1 toxic. But the fact it is not infectious means it is not 6.2, an infectious substance. The fact it is neither radioactive nor corrosive means it is neither class 7 nor 8. And last, the fact it does not bioaccumulate and is not a marine pollutant means it is not class 9. So we're left with looking in detail at class 6.1. The criteria for class 6.1 are largely based on LD50, the dose required to kill 50% of the test animals. And where do we get that information? Well, as with the TDG information, commonly from the safety data sheet, this time section 11. The slide shows an excerpt from the sodium cyanide safety data sheet. And the criteria for 6.1 are an LD50 oral, that is given by mouth, of less than or equal to 300 milligrams per kilogram. Sodium cyanide's value of 5.733 easily meets that criteria. The second criteria is an LD50 dermal, or administered through the skin, of less than or equal to 1,000 milligrams per kilogram. Again, sodium cyanide's value of 14.602 meets that criterion as well. So sodium cyanide does meet the criteria for a toxic product. Are we done? No, we still need to determine the packing group. The criteria for packing group 1, the greatest danger, for class 6.1 are an LD50 oral of less than 5 milligrams per kilogram, an LD50 dermal of less than 50. Sodium cyanide's oral value of 5.733 is too high for packing group 1. However, its dermal LD50 is well within range. As we always take the lower packing group, we classify sodium cyanide in packing group 1. And our final conclusion? Sodium cyanide is class 6.1, packing group 1. And does Schedule 1 agree with us? Well, what do you know? Column 3, class 6.1, column 4, packing group 1. And all of that leaves just one more item to discuss when it comes to classification. What do you do if you have a product that falls into more than one classification? For example, see the methanol entry on the slide. We know from our rules that the primary class is 3 because it is not in brackets. But why is 3 the primary class? The basic rule is that for dangerous goods that fall into more than one class, like methanol, the class deemed most dangerous is the primary class. All of the classes are subsidiary classes. That still doesn't answer the question about how you determine which class is more dangerous. Basically, there are two separate ways. For gases in class 2, there is a set priority shown on the slide. Class 2.3 toxic is the most dangerous, followed by 2.1 flammable gas, and lastly 2.2 non-flammable and non-toxic gases. For example, take arsine, a gas formed by mixing arsenic with acid. It is both toxic and flammable, classes 2.3 and 2.1. Since 2.3 is higher than 2.1 on our list, 2.3 is the primary class. That's okay for gases, but what about our methanol, which is liquid? For liquids and solids, the regulations have a table of precedence, which tells you the primary class for any combination. Thinking back to methanol, we have class 3 packing group 1 and class 6.1 with no defined packing group. Looking at the left-hand column on the slide, we find 3.1 packing group 1 right at the top. Moving over to the right, we look under the class 6.1 columns to find the cells circled in red. For all packing groups, class 3 is the primary class, and 6.1 is the subsidiary class. And that yields the entry that we see in Schedule 1. And that concludes our discussion of the classification of dangerous goods and the use of Schedule 1. I invite you now to move on to Module 3, where we will discuss some exemptions to various parts of the transportation of dangerous goods regulations.